Hey, so welcome back, and this is another daily LeetCode problem. So today's March 19th, and it was another try question actually. So let's take a peek at it. So yesterday was also a try question, but it was actually about creating the data structure itself, and it wasn't really much of an algorithm or a LeetCode problem behind it. It was just knowing how to produce that data structure. And so it's kind of like having to implement like a linked list class using some nodes. And so because the try data structure is very similar to a linked list, you do actually have to have like kind of nodes and chains. But just let's quickly overview what a try data structure looks like. And so what we'll do is we'll kind of use some of this example. So they have our root at the top. So a try data structure always has like a root at the beginning. And then from there, it has some nodes kind of in the first level below it. And so it has B here, and then this letter starts with D. And then we'll just add the third one, M, for mad. And then so from here, they kind of have chains that go down each path. And so what you see here is because all of these have different kind of first letters, they don't really kind of reuse any of their kind of paths. So all these characters here, they're all repeating, but they all share kind of different prefixes or different first letters. And so what's nice about a try data structure is you can actually reuse it in some cases where, say, like we want to spell Bob, we would then reuse this B since it's already at the very start, and then we'll just put B, O, and then B. And so the other thing is that you actually have to mark kind of the end of each word. And so that's another attribute that you have is like we say, okay, this is the end of that bad word. This is the end of that word named Bob. This is for dad, and this is for mad. And that's useful because what if you have what if Bob is the prefix of another word, like Bobby in this case, then you can kind of put Bobby here and then just mark its ending like that. So a try is very popular data structure for like completing words like autocomplete or for searching, your history or, on Google or whatever. So very useful data structure, not that common in like interviews or in competitions, but it's very good practice and helps you work with like depth first search and linked lists. So yeah, so let's go ahead and solve this question. So there's only one difference between kind of creating the data structure itself like you normally do and this problem, and that's that you have to deal with these kind of stars, or it's a dot in this case. Usually it's represented as a star in like SQL or in like regex. It kind of means like anything. And so this caveat is that, say we have a root again, and we have like B, then AA, and then we have like C, and then whatever, like D, E, and then F. And so this works so that, say if we have like, we're trying to match, and see if we have a word like dot EF, that dot kind of means that, okay, we can kind of go down any of the paths at the beginning. So any of these first words is an eligible candidate. And so what you would do here is you would say, okay, is there anything basically that has some letter and then ends with EF? And so we'd say, okay, this is a letter. Does it end with EF? No, it doesn't. Okay, well, with this one, does it end with EF? No, it doesn't. And does this one end with EF? And then yes, it does. And so that's the only difference, is you kind of have to have like a second loop to be able to check not just like kind of the first character, but say, okay, does this work? No. This one, no. And then this one, okay, yes, it works. So we'll go ahead and solve that at the very end. We'll first kind of implement it how you normally do with a try of just searching without this dot, and then we'll end by, okay, let's add this dot and see what the difference is. So first, what we're going to do is we're going to create our node, and this is going to be kind of each character on that chain. We're going to specify it as a node in our class here. And we're just going to grab our constructor, and it's going to have two attributes. The first one is the children, so that's like the eligible kind of branches that branch off from that current node. And so it's going to be a hash map like this. And we're then going to have another attribute that says like is ending. And this initially would be false. And that's used just like I was showing, so you can kind of mark as like, okay, this is the end of a particular word. Okay, and so to initialize it, we just create a root and we call that node. That's the root I was kind of keep showing there. And that's all you need. For adding a word, this is the exact same way as how you would add a word for a try data structure if you're implementing kind of the try class. And so you just grab our root and we'll mark that as like our current node. And we just want to say, okay, for every letter in our word, we want to go through our word and just say, okay, if our current node has a child with that letter, then we just want to kind of continue down that chain, because we don't want to kind of add an extra node in that row if it already exists. We just kind of reuse it, kind of like we did with Bobby and Bob. Okay, and so we just set our current node equal to that child node. Otherwise, we're going to have to create that node. And so that's done just by saying, okay, our current node dot children at that index in our hash map is going to be a new node. And then because we want to kind of continue down this chain, we just set our current node equal to that, what we just made. Awesome. And then finally, we have to make use of this is ending. So we just want to mark our current node as the ending for a particular word. Great, and that's all to add a word to our try data structure. So to search in it, what we're going to do is just kind of implement the easy way of just searching and not having to handle with this dot. And then we're going to look at, okay, how do we handle that case? So we once again just grab our root and we set our current node. And we just want to loop through every letter in our word. And once again, we just check, okay, is there a current node? Or is there a child at our current node with this letter that we want? And if so, we just kind of continue down this path. Otherwise, we're actually going to return false immediately because, well, if there's no kind of character that we need in that chain, then we know that it breaks the chain and there's no sense searching anymore because there's no words with that prefix. Okay, and so next at the end of this, we're just going to return true only if our current node is an ending of a word. Because maybe like, yeah, we didn't actually insert this word yet and mark it as the end of a word, right? It could just be like the prefix of an existing word. It'll just move me over here. Great, and so from there, let's see. Current word, we look through every letter, children. We then grab our current node if it's there, otherwise return false. That looks good. And so now we need to like enrich this method so that we can handle these kind of dot cases. And so once again, we kind of have to do this recursively. And we're going to pass in our kind of current node, and we're going to pass in the string that we're looking at. And so we're going to return the result of this depth first search function. Okay, and so the reason why we want to put this in a function now is that we're going to have to reuse a lot of this logic when we're looking at those dot cases, because you can kind of go down any of the paths in our kind of chains that are eligible chains. And so we're going to need another case here that checks, okay, if this letter like is equal to our dot case, so then we're going to want to kind of call this depth first search method again, or function, and kind of recursively be checking all the different chains that are eligible. And so what you do is you just want to get the eligible chains, you just look at our children hash map. And so because our hash map is kind of designed in a way that it's the letter corresponding with the node. So then you just say, okay, we'll iterate through for every node in our current node's kind of children hash map. And so we get all the values. Makes sense. And then we just want to depth first search on that. And so now that we have to pass in the word again, because we already pre-processed a lot of the letters that came before it, we don't want to have to kind of rerun those again. And so we want to actually slice our string. So we just say, okay, s at the current index that we're looking at, +1, since we don't want to include the kind of dot word, since you can pretty much ignore it. And then you just kind of recursively check it. So to get that I, we actually have to enumerate this. And I think that's it. Oh no, so we want to return true if any of these chains turn out to be like positive, where this is a positive path for what we're looking for. And so we return true. Otherwise, if we iterate through all our eligible chains and you can't actually create it, if all our eligible chains are false, then we want to return false in that case. Oh, I just forgot that. And I can't see that error. Yes. Needs a colon. Oh, and someone's hammering next to me. I don't know if you hear it. Key error B. Okay, for every L. Oh, we want to say, okay, if that letter is in our hash map. I think same thing here. If our letter is in our hash map. Oh, and these are all false when they should be true. Let's see here. So if our depth first search at our node, oh, because you have to mark this as true for a current ending. Yeah, accepted. Takes a while to judge it. And success, and it's a pretty good performance. So yeah, that's pretty much it. Same thing as kind of creating your own tri-node data structure or your tri data structure, except there's this one caveat with a dot, and you just have to recursively go down every single path to see if any of the chains are eligible. And naturally, if none of the chains are kind of working for what you're looking for, then you just return false immediately. And the only other trick, I think, is just you need to kind of slice it so that anything that you kind of were checking down the chains before it to get to that place, you don't want to process those letters again because you already got there. So you just kind of minimize your word going into the next recursive call. So yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks.